You've heard me talk about the engineering design process before on this podcast as a way to plan and also have students problem solve through their projects. If you are curious to learn more about this process, I encourage you to go back and listen to episodes 15 and 17 through 21. While the audio from this episode has never been heard before on this podcast, this presentation I did in the past at an online summit. I'll be sharing with you how to plan with the engineering design process, share student examples that are planned with this process, and helpful tools that you can use for planning. Welcome to the Elementary STEM Coach Podcast, a show that'll help you with lesson ideas, systems, and actionable tips to apply to your classroom. I am your host, Naomi Meredith, a former classroom teacher turned current STEM teacher and coach. With over a decade of experience teaching and a master's degree in STEM leadership, I am here to coach you throughout the year to help you gain back more time to create innovative experiences for your students. Grab your earbuds and let's get started. Hey there, and thank you so much for joining me today in this fun session where we are going to be talking about creating engaging STEM projects using the engineering design process. This session is geared towards teachers who are in the elementary space. Whether you are a classroom teacher, a specialist, a STEM teacher, or even if you're a homeschool teacher, this session is perfect for you. Also, for teachers who teach older students who are needing content at the elementary level, you can definitely gain some insightful information that you can definitely take back to your classroom and your students. If we haven't met before, I am Naomi Meredith. I am a former classroom teacher turned current K-5 STEM teacher, and my goal is to help teachers like you creating STEM amazing experiences in your classroom that are highly engaging and centered around standards. So definitely in the right place. We do some really cool things in my classroom, but they are very, very purposeful. And I would love, and I'm hoping that you love to do those same things with your kids. So the goals for this session, there are 4 parts. First, we're going to talk about what is the engineering design process. So maybe you have heard the term, but not quite sure what it is, or maybe you have an extensive background. We're going to have a common understanding of what the engineering design process is. Next, we're going to talk about ways that you can plan using this process. Then the fun part, well, it's all fun, but extra fun, student examples, and then some tools that I have for you to help you with your planning. So first of all, what is the engineering design process? Or maybe you have heard the abbreviation, since we love acronyms as teachers, the EDP. Well, it is a real process that real engineers use to ask questions, find solutions, and iterate ideas. So this is a real life thing. And this is something that I tell my kids all the time when we use this process for most of our projects, that this is a real life thing. This isn't some random thing that I made up that I'm teaching them. This is how projects are created in the real world. And sometimes we go through that real process. Sometimes we don't get through all the steps. Sometimes we go back to other steps. But these are things that it's a whole process that engineers are using to design these solutions, which is really applicable to kids, especially since they might ask you, why are we doing this? It's important for them to realize that. Also, there is a big reason why to teach it. So yes, we know real engineers use it, but why should we even teach it? Well, first of all, a lot of us and most of us use the standards. So the Next Generation Science Standards actually have in K-2 and 3-5 the engineering design process. So go and check those out. They are different than the content level standards, so they actually have their own categories. So definitely recommend to go see those. And the cool thing about it is that you can actually apply this to any type of content. So they're not tied to just one specific thing like earth science or space science. You can use the engineering design process with any content area, which you're going to see when I talk about the student examples. Also, the engineering design process is different than the scientific method. And in my opinion, both are good for different ways. When you read through the standards and when you're thinking about your content, not every standard works well when it comes to the engineering design process. Not everything can be solved through this method. Likewise, there are times when you do need to conduct a science experiment, where you do need to go through those multiple trials to compare solutions, to have a sample that you're comparing to. That is definitely appropriate for certain topics that you're studying about. And then there are times that you do need to dive in deeper and think of multiple solutions. Again, we're going to talk about keywords and how you can actually pick out those standards that can work well for your projects when you're planning these creative projects. And of course, how it is different than the scientific method, and it's very straightforward and you have to draw conclusions in the scientific method. But with the engineering design process, you're definitely promoting creative problem solving. So yes, you have a solution, but there are multiple solutions to get to that answer. And you can even improve that solution you come up with. So it's really cool to see when you do projects like this, that all of your students' work is going to be different. If you are really truly planning an open-ended project, the solutions are going to be different and you're going to want to encourage that. Yes, there'll be similarities, but it's not a cookie cutter thing, which is so relieving in some ways because it can get boring to see all the same stuff. So it's really great to pull out that creativity when you plan in this way. So speaking of planning, how do you plan using the engineering design process? Well, it's not as complicated as you might think, and it actually is a whole lot of fun once you get into it. So I went through the next generation science standards. And again, if you use different standards, you can definitely use this process, but you definitely want to become familiar with those. And especially for me, when I teach K through 5, I'm in the standards all the time because there are so many different content areas that I need to know about. But when it comes to your specific science standards, look for keywords when you are planning with the engineering design process. You want to be thinking about those keywords like this kindergarten one. Use a model to represent. Well, you could definitely have students, yes, they could use a model, but they could also create the model to show the relationship of the needs in different plants that it talks about in this standard. Another keyword you could look for, generate and compare multiple solutions. Generate can be a physical model. It could be a digital model. It could be a video. That could be the solution. It could be a drawing. So there are a lot of ways to generate a solution. It doesn't necessarily just have to be writing out a paper, which it could be, but it can be more creative and fun than that. Also, another good one, use materials to design a solution. That right there definitely shows me I could definitely do a makerspace project when I am teaching an engineering design process lesson. So definitely become familiar with your standards. They aren't a bad thing. And honestly, coming from somebody who I was given a brand new classroom with a brand new to me district with zero curriculum and minimal tools, the standards have always been my base and my go-to, and along with the engineering design process, to really create high level lessons out of nothing. And you definitely get used to it and really go through that planning process. So as a snapshot, here are the different stages of the engineering design process. You might see them named different things or labeled in a different way. This is how I break it down in my classroom. There's similar words, different, but this is basically what it is. So first you have an ask. So what is the problem that you are trying to solve? And there is a way that we'll talk about how you should phrase this. Ask this problem, you could definitely have pre-made as a teacher. So you could have this all ready to go. And so you could dive into the topic, or this could actually be created together based on investigations. Maybe you did do the scientific method the week before, and then you use that data to create an engineering design process flow. So what is the problem? Then you go on to the imagine stage. So what are the possible solutions out there? So using a lot of different tools to research, multimedia tools to really gain information about the topic. This could be short video clips, infographics, ebooks, articles, paper books that you have, real life research, a guest expert. So gathering lots of ideas to inform your decisions and when it comes to the plan. You notice that the create stage isn't the first stage, and the kids, of course, love that. Yes, we love the building, but even when I first started teaching STEM, the kids wanted to jump into the create, and I'm all, well, yeah, that's cool, but we can actually have a better project if we do all these other steps. And it did take some training along the way, and they're so used to it, and their projects are so much better and they make a lot more sense. So really going through this process is super helpful. So using all those things that you find in the imagine stage, that can help inform your plan. So what could your solution look like? It could be multiple solutions. What are all these different ideas that are buzzing around with your head that could help answer that ask? Now, the arrows really should be going back and forth. You can go back to the stages at any time. But once you have a plan in place, a thoughtful plan, then you can actually bring your plan to life. And sometimes we always get stuck up on that create, but yes, you do get to create. And through that creation, you want students to be experimenting and improving. So testing and making those designs better through different avenues, and then giving them the opportunity to share. And that could look in a lot of different ways. So you could teach each process day by day. There really isn't any rhyme or reason as to how long you should have an engineering design process be. I can go through the process all within 5 days, typically 2nd through 5th grade, but sometimes I even pare down those lessons even more for my younger students. So it definitely can be differentiated based on the needs of your students. So when we think about the ask stage, so that is that first stage in the engineering design process. What is that problem? A great way to phrase things, and when you really want to have kids have multiple solutions, think about how you word the question. Instead of saying, can you create blah, 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 shift your question to how can. Just by the change of those two words can really open up the problem. And again, open it up in a way like, can you? Yeah, I can do it. But how can is like, oh, well, how can I do this? What could I do to solve this problem? So thinking about the way you word the question will really help out from there. So when you are planning out these projects, there are different project types, and these aren't all of them, but these are really popular ones in the elementary STEM space right now. And I broke them into categories based on your experience level and where you might be at and what you might want to try. So if you're just getting started with STEM projects in general or with the engineering design, here are some places that I would recommend to start. So of course, digital citizenship is super important. This is a lifelong skill for every person out there, and how to interact in the online space with so many different things. And so you could even think of some STEM projects that could relate to the digital citizenship lessons that you are doing, and the engineering design process can fit within that. Then, of course, we have makerspace lessons, which you could use any materials that you have on hand, recycled materials. So building to solve a problem. And along with that, if you have Lego builds, this could include having a mixed bucket of Legos to build and solve your problem. Or maybe you have Lego education kits. There are a lot of open-ended projects in there and getting started lessons. So one or the other is really great. But if you're just getting started, I would definitely start with these topics. Now, if you're needing an extra challenge or want some more inspiration, a next great step for you in no particular order is adding in an element of robotics. There's a lot of different robotics you can use with various grade levels, and you could tackle those projects. Then you can do some computer coding. There are a lot of great free programs out there, so definitely recommend checking out the Hour of Code website or code.org. Then you can do some 2D design. Say that 3 times fast. 2D design. And maybe you want to cut out their designs using some sort of cutting feature like a Cricut machine or a Flash Forge. Maybe they're designing using things like Canva or Google Slides, things like that. So thinking about that digital 2D design. Then if you want to move into some elements of animation, motion animation is great. There's a great free tool out there, Stop Motion Studio. I almost got the name wrong. That's another one to say. That's really hard to say fast. And then green screen's also another great option when it comes to video production, that you can have students present their work. So those are some great extra challenge pieces. And for the most part, most of that actually is not too bad to get materials. And then if you want even more of a challenge, and this might even come with what kind of materials you might need, 3D design is awesome and definitely can integrate with the engineering design process. You don't necessarily have a 3D printer. You can do all the design without it, but if you have a 3D printer, yes, you can do it. And when I say 3D design, I do this K through 5. So even kindergartners are designing something for the 3D printer. So it can be done, guys. Then video production, which is a whole big thing that is a great skill for anybody to have as well. So that could be just recording on camera and or video editing so they could edit those recording things or even add in animations to those videos. Or maybe the whole video has different animations and they have a narration on top. So video production is a huge thing that can definitely level up anybody in our modern world. And then podcasting, along with that, podcasting can be a great tool. Not every kid loves being on camera, but they have a great voice for podcasting. So not to toot my own horn, but I have a podcast, the Elementary STEM Coach podcast. So again, another great skill. And then this only thing on this list I haven't experimented with yet would be drones. Drones are a huge, big thing, and that could be a really great addition to the types of lessons that you plan. So next, I'm going to talk about student examples just to get your wheels turning. And all of these examples that I'm going to share for you are kind of random. I picked a lot of different projects. I have one per grade level because I wanted you to see various projects that you can do with the engineering design process. I'm going to give you a snapshot of each lesson. Again, these don't come together as a cohesive unit, so don't judge, be like, what? This doesn't relate to the next one. Yes, they don't. They don't relate at all. They are just a collection of things just to give you some ideas. So as you are looking through those standards, then you can say, oh, I could do a makerspace with this, or oh, I could do robotics. So just giving you a feel of how you can do that. The way I do plan my units, I do use these project types. So if I'm doing digital citizenship, everybody's doing digital citizenship. If I'm doing makerspace, everybody's doing makerspace. So just keep them in mind when I'm explaining this. So if kindergarten's doing this type of lesson, everybody else is too, in their own way and different content. So speaking of kindergarten, for this lesson, it went along with my STEM amusement park. So a hand-on makerspace unit where all of the grades were talking about things that had to do with force and motion. And for this one, students were creating one section of the STEM amusement park, and they were talking about force and motion and how they can change the motion of the ball. And I'm going to be explaining the standards, but don't judge if I get the standards wrong. Again, I'm giving you a snapshot. So students design their very own wall maze using materials we have on hand and then see how many marbles they can collect in the bucket. This is really good for their fine motor skills, even when it comes to just ripping the tape and putting it up, but also thinking about what materials they could use and add on to their design throughout the week. So this project, I would probably say, takes about 3 days with kindergarten, and we go through that whole engineering design process for all of these. For this project, for first grade, we talk about the elements of 3D printing and how animal babies and their adults have similarities and differences when it comes to their physical traits. So a lot of times the parents will pass down those traits to their babies, and it's very apparent when they're born. And other times as they grow up, those traits seem to appear later on. So as we research through these things, students pick their favorite animal through their research, and then they design their own little family, baby, animal, and adult, with our 3D printing software. And then once they're done printed a month later, it does take some time, then they color in their animal character with some Sharpies we have on hand. So this was our 3D printing unit. For Earth Engineer, a different makerspace unit, so students are taking on the role as an Earth Engineer. And in second grade, we were talking about how there are different things that can shape the land. And we were talking about one specific way, and that was erosion, and specifically more of that water erosion. So there are a lot of different types of erosion, but we specifically talked about water erosion. And students researched different types of solutions that are already out there to help slow down the effects of water erosion. And then using those ideas, they thought of an original idea or progressing off of ones that they saw to create a design that will help slow down the erosion that is caused by the water. So you can see on the image that students were planning their designs thoughtfully using a digital tool. I love Seesaw. If you listen to my podcast, you know that I talk about Seesaw a lot. Not sponsored. And then they use different materials, makerspace materials, to design their solution and then test it, which there is some of that scientific method in there. For a third grade idea, if you're thinking about getting into more of that digital production, this was not 3D. This is a green screen project. So the whole unit was about video and audio production. It was Earth and space science. And third graders were taking on the role kind of like a travel agent. And they were explaining more about the weather and climate in a location in the world, and to get people excited to travel there and talk more about what it's like during the different seasons. So students researched, they wrote a script about their different location, and then they edited their background to match the words that they were saying. So you can see me on there on the screen. I was very excited to do this. I didn't give you the screenshots of the video that I made that it looked like I was messing up on purpose, but hopefully you enjoy that. This is all about Costa Rica, by the way, if you were wondering. For fourth grade, actually similar unit to that water erosion one that I was showing you, but students were an earth engineer, and they're taking on the role of a civil engineer and using GIS, Geographical Information System data, to create a landscape. So to create the map of the landscape that they were built to build their city on. So you can see on the right that students were using the data to color their grid. So there's grassy areas, there was a river, there were muddy areas, and then using that information that would inform their decisions on how that they would build their city design that included different elements. So they were shopping for their supplies, and then they started to build their city from there. I'm giving you a lot of makerspace ones because these are a great way to get started. And then this one was the first unit of my year. So my first unit that I do with my students is actually about introducing the engineering design process, and that is STEM Survival Camp. So students come back from the summer ready to go in my class, and I decorate the classroom all for STEM Survival Camp. I wear a different camp shirt every day. And for fifth grade, we were talking about different weather hazards, and that their challenge was to design a shelter to withstand the elements. So you can see as students plan, they were thoughtfully planning that by drawing different angles, and they were also explaining different parts of their design. And then using some materials that I provided them and also things that they collected from the outside, they had to build a shelter where they would actually test with different elements. So we tested the wind, the rain, and the snow was glitter, which I know not everyone's a fan of glitter in the classroom. I don't mind a little sparkle on the floor. It's like a unicorn ran through there, and I'm all for it. So this is a great way to start off the unit. All of their projects, again, were more simple and basic, and get them accustomed with the engineering design process, and as a refresher, and use some elements from the outdoors. So you can even think about, for the end of the school year, how can you take some of that learning outdoors as the weather gets nicer and use it to your advantage? So I talked about a lot of different examples for you. Again, a lot of different hands-on and makerspace things to help you really wrap your hand around all of these fun different things you can do in your classroom. Like I said, most of my projects will take about 5 days. So if you're thinking about your schedule, just leave yourself enough time when it comes to planning things with the engineering design process. Now, I wanted to mention some resources for you that definitely you should check out to help you with this process now that your creative juices are spinning. Definitely check out the bundle pack that is part of this conference. There's a whole session I contributed in that pack, so you can have a resource where I'll walk you through on how to exactly plan an engineering design process lesson from start to finish. You will get planning templates, you'll get planning slides, and then you can definitely tackle and really dive in deep into those engineering design process lessons. Also, you can check out this free podcast playlist that I put together for you. It's all about the engineering design process. So I pulled from my regular show, the Elementary STEM Coach podcast, but I put together all of the lessons from that show that talk specifically about the engineering design process. So I go more into depth into all of the different stages of the engineering design process. So the ask, imagine, plan, create, experiment, improve, and share. And then there's also some cool interviews in there. So definitely check that out. The link is up on the screen, or you can get that free playlist at naomimeredith.com/podcast playlist EDP for engineering design process. And then also, if you just want to see how I plan with this throughout the year, you can download a free year-long plan. You can grab that at naomimeredith.com/year-long plan and see how everything groups together using this process. Of course, I would love for you to reach out. So if you have any questions, let me know. I'm most available on Instagram. So at Naomi Meredith _ you can definitely send an email my way. Contact NaomiMeredith@gmail.com. Definitely check out my website, NaomiMeredith.com. And you can even find my podcast on there. Like I said, the Elementary STEM Coach Podcast. So thank you so much again for joining me today. I so appreciate your time, and I hope that you enjoyed this as well and have a great time getting started with creating engaging STEM projects using the engineering design process. This presentation had a ton of visuals, and I bet you are dying to see all of the examples and handouts. You can grab the video recording of this episode, the video slides I referenced throughout, student examples, and bonuses for only $5. That's less than a fancy coffee drink. This will all be linked in the show notes, and you can check it all out here at naomimeredith.com/PD replay. Thank you so much for listening to today's episode of the Elementary STEM Coach Podcast. I would love to connect with you over on Instagram at Naomi Meredith _ or send me an email to elementarystemcoachpodcast@gmail.com. Also, make sure to check out my website, naomimeredith.com, to see all the show notes from today's episode and shop my K-5 STEM resources. Any questions you have, needs for resources, or ideas for episodes, get in touch. I'll talk to you soon.